Good morning to all of you. Today we will discuss here the derivation of some useful inverse trigonometric formula. In this sequence, first we prove that 2 sin inverse x is equal to sin inverse 2x under 1 minus x square. For this, let sin inverse x is equal to theta, and this will be sin theta is equal to x, and we know that cos theta is equal to under 1 minus sin square theta. Therefore cos theta is equal to under 1 minus x square, and we also know that sin 2 theta is equal to 2 sin theta cos theta, and by putting the value of sin theta cos theta we get sin 2 theta is equal to 2x under 1 minus x square, and this will be written as 2 theta is equal to sin inverse 2x under 1 minus x square, and by putting the value of theta we get 2 sin inverse x is equal to sin inverse 2x under 1 minus x square. And in the similar way, 2 cos inverse x is equal to cos inverse 2x square minus 1. For this, let cos inverse x is equal to theta and cos theta is equal to x. Since we know that cos 2 theta is equal to 2 cos square theta minus 1, and by putting the value of cos theta we get cos 2 theta is equal to 2x square minus 1. This will be written as 2 theta is equal to cos inverse 2x square minus 1, and by putting the value of theta we get 2 cos inverse x is equal to cos inverse 2x square minus 1. And in the similar manner we prove that 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. For this, let tan inverse x is equal to theta and x is equal to tan theta. We know that tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta, which is equal to tan 2 theta is equal to 2x upon 1 minus x square. This implies 2 theta is equal to tan inverse 2x upon 1 minus x square, and by putting the value of theta we get 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. This is the value of 2 tan inverse x in the form of tan inverse x, and 2 tan inverse x is written in the form of sin inverse and cos inverse also. For this we know that tan sin 2 theta is equal to 2 tan theta upon 1 plus tan square theta, and by putting the value of tan theta we get sin 2 theta is equal to 2x upon 1 plus x square. This will be written as 2 theta is equal to sin inverse 2x upon 1 plus x square, and by putting the value of theta we get 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square. And we also know that cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta, which is equal to 1 minus x square upon 1 plus x square, and this will be written as 2 theta is equal to cos inverse 1 minus x square upon 1 plus x square, and by putting the value of theta we get 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. So there are three formulas of the 2 tan inverse x in the form of tan inverse, in the form of sin inverse, and in the form of cos inverse x. And there are some more formulae which can be proved that 3 sin inverse x is equal to sin inverse 3x minus 4x cube, and 3 cos inverse x is equal to cos inverse 4x cube minus 3x, and 3 tan inverse x is equal to tan inverse 3x minus x cube upon 1 minus 3x square. Now we will also prove that sin inverse x plus sin inverse y is equal to sin inverse x under root 1 minus y square plus y under root 1 minus x square. For this, let sin inverse x is equal to theta and sin inverse y is equal to phi. This will be x is equal to sin theta and y is equal to sin phi, and we know that sin theta plus phi is equal to sin theta cos phi plus cos theta sin phi. and this will be written as sin theta, and cos phi written as 1 minus sin square phi, plus sin phi and cos theta written as 1 minus sin square theta. By putting the value of sin theta, sin phi, we get x under root 1 minus y square plus y under 1 minus x square. This will be written as theta plus phi. Theta plus phi is equal to sin inverse x under 1 minus y square plus y under 1 minus x square. And by putting the value of theta and phi, we get sin inverse x plus sin inverse y is equal to sin inverse x under 1 minus y square plus y under 1 minus x square. Similarly, we can also prove that sin inverse x minus sin inverse y is equal to sin inverse x under 1 minus y square and minus y sin under root 1 minus x square. In the similar way, we can also prove that cos inverse x plus cos inverse y is equal to cos inverse xy minus under 1 minus x square into under 1 minus y square, and cos inverse x minus cos inverse y is equal to cos inverse xy plus under root 1 minus x square into under 1 minus y square, and tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, and tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. This is the sum formula which is used in the next exercise. For today, this will be sufficient, and thank you very much.